say, ew, what is this? Alright, truth tables. Truth tables, also known as logic tables. This is beautiful.
This is so horrifying.
What? This is great. No, not yet. I remember doing truth tables in Math 200 with Dr. Skimbortis. Dr. Skimbortis. He was originally from Israel, and he was a precious guy with a mustache like this and a comb over. He was so wonderful. I also had him for real analysis and physics too. I think something else. Is he interesting? He was very interesting. And he had glasses. And he went to Planet Fitness at 4 o'clock in the mornings, which I just think is precious. Okay, truth tables. So a truth table is basically a table in which we look at whether the statement's true or false, and we compile that to gain more from it. So it's a logic table that gives you the possible true and false for each letter. And then the table asks you to state the true or false for additional statements using what we know. So the letters P, Q, and R just represent a statement. So like the statement, I love math, might be P. And the statement, I love green, might be Q. And I love cheese. I do love cheese.
Cheese tastes so bitter though.
I do. Cheese tastes so
Everything tastes bitter.
Alright, so P, Q, and R just represent statements. That and K, please get your heads up off your desk so I know that you're awake and with us. Thanks. Alright, and remember the notation of this little squiggle guy means not. And now we have two more things. This V looking shape here, that means or. That's the notation for or. I lost my smartboard marker here. And then this carrot thing means and. Okay, now this is important to remember because you're going to have to fill out these truth tables on your own. It's so much fun. Alright, so an or statement. Say I'm just looking at this here. I love math. Or I love green. An or statement. In order for the entire statement to be true, in order for the entire or statement to be true, either the first one has to be true or the second one has to be true. Alright? So in order for the or statement to be true, either the first or the second. So for an or, either one. Now for an and statement to be true, if I say I love math and I love green, in order for that statement as a whole to be true, both pieces have to be true. So for me, this is a true statement. I love math and I love green. Peter, do you love math? Yes or no? Do you love green? Okay, well then that's just a false statement for you. Anybody love green? Is there anyone that loves green that does not love math? So then this is a true statement for, oh wait, I'm using and, sorry. Raise your hand if you love math and you love green. Okay, so for Cade, Ian, Amina, and I, this is a true statement because both have to be true. Alright, so in order, we can use another example. Say our two statements are, I am human, I am a mammal. I am human and I am a mammal. That is a true statement overall. Now, if we looked at the or statement, I am a human or I am a mammal, then notice there's more beings that meet that qualification. So, and P and Q must both be true for an and statement to be true. Alright? The only time, this is important, the only time an and statement is true is when both pieces are true. Okay. The only time an and statement is true is when both pieces are true. Okay, so let's take a look at our first truth table here. go Matthew. Keep your head up. Okay, so here are our three letters P, Q, and R. Let's ignore all of this here. Okay, so we're just looking at P, Q, and R. Now we're looking at every possible combination of true and false for these. So we're looking at every possible combination. We have 1, 2, 3, 4, 5, 6, 7, 8 different combinations. There's actually a mathematical way to know how many combinations. You may learn that. You may remember that from 7th grade. The different possible options. I have true or false. So 2 options for P, 2 options for Q, 2 options for R. 2 times 2 times 2 is 8. Remember that from 7th grade? I know you learned it then. I tutored a 7th grader this past year, and he learned that. Don't worry, you'll do it again in Algebra 2. Okay, so anyways, we have 8 different possible combinations here. Now, my recommendation for setting up your truth table, because we will be giving you tables that are completely blank, my recommendation to make sure you don't miss any particular scenario, the way that I set this up when I did these is to make the first half of them true, and then the second half of them false. And then in the next row, do chunks of 2. True, false, true, false, true, false, true, false. Alright, and then in the final row, alternate. Now, if we only had P and Q, we wouldn't have as many combinations. You'll see that in the one below it. When we do that, you'll see there's not near as many combinations. There's only 4 combinations. But so my recommendation is split it in half, and then do half of that true, true, false, false, true, true, false, false, then half of that until you get down to where you're alternating. That's my recommendation for setting up to make sure you don't miss any scenarios, but you can set it up however you want, as long as you have all the scenarios. So that's my recommendation. Do half true, half false, and then half of that, and then half of that. Okay, so you can see it. It's like a half-life. Did you guys learn half-life yet? Biology, I think?
I think
Are you taking biology right now? Yeah. Okay, well, you'll learn about half-lives. Okay, so you can kind of see that format there. Half of it true, half of it false, and then half of that, and then half of that. All right, so we start off by writing the different possible true falses for our statements. And then we want to ultimately figure out when this statement is true and when it is false. Now notice the different components we need. I need to have the component not R. That's why I have a column for not R, because I need to have that component. I also need to have the component not P or Q. As you can see, we have a column for that. Well, within there, I need the component not P, and as you see, I have a column for that. I need Q, I have a column for that. I need not R, I have a column for that, so I need P, Q, and R. So you can see that I have a column to take care of every component within my final statement. All right. So let's take a look at how this works. I think it's helpful to cover up the statement sometimes. All right, so we have P. Now let's take a look at not P. For visual sake, I'm going to cover up Q and R. All right. If P is true, what is not P? False. If P is true, not P is false. True, false, false. True, 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 true. Oh, look at how easy that was. So we're going to be deciding if it's true or false for every single cell within the table. All right, questions on what we just did there? Okay, so the next thing we need is not P or Q. So for that, I'm going to look at I need my not P column. So I'm going to look at this column. And I need to look at Q. Alright, that's where I'm going to get my information from. So let me cover up P and R, because I don't need those, right? I just need my Q column, and I need my not P column. And it's OR. For an OR statement, either one has to be true for it to be true. Alright, so either one has to be true for an OR statement to be true. Not P or Q. Are one of these true? Yes. So that means that my statement is true. Okay, for an OR statement to be true, either one has to be true. One of these true? Yes. So it's true. So again, what we have going on here is not P, we're looking at this column. Q, we're looking at this column. And we're considering OR. An OR statement is true if one or both of those, either one, is true. This first row, I have when Q is true and not P is false, one of them is true, so the OR statement is true. So, not P or Q, is one of them true? Yes. So that statement itself is true. Same with the next one. Not Q or P, is one of them true? Why, yes. So the whole statement is true. So the next row. Not P is false, Q is false, so what's the OR statement? False. Questions so far? It's just a lot to keep track of. So I have false and false. OR statement, false. I have true and true. For an OR statement, I only need at least one to be true. Well, we've got both. Great, we've got more than we need. So it's true. Or you need either one to be true. So it's fine to have both true.
Wait, so
I love math or I love green. If I satisfy one of them, great. Fine. So if I love math, great. The OR statement's true. If I love green, great. The OR statement's true.
If they're both true, then it can't be OR. It's like one or the other.
No, for an OR statement, you need at least one of them to be true. If both are true, great. Now, of course, that's the same thing as saying, and I love math and I love green. But for an OR statement, if both of them are true, great. The statement itself is true. So, Mrs. Margraf loves math or loves green. Is that a true statement? Yeah, because I love math. I love green. Now, Kayla loves math or loves green. Is that a true statement? No, it's false because she doesn't like either. You don't like either? She doesn't love either, so it's a false statement. Alright, so then true, true? True. False, true. Still true. For an OR statement, we just need at least one to be true. It's alright to have both true. False, true. True. We're finally at the end. So if you think about it, for an OR statement, you're going to have it most likely be true more often than not, because you only have to satisfy one of the requirements. It's more often that you satisfy one or the other. Great, questions so far? Okay. So now we're going to look at not R. So we're going to look at this column here. If R is true, what is not R? False. So let's go through this quickly.
I got the first one.
It's opposite. Not is just the opposite. It's either true or it's false. So if it's not true, then it's false. If it's not false, then it's true. Alright, so finally, our big grand finale. What we're trying to get to, what we were trying to do this whole time, is figure out when this situation is true, when is it false. We're looking at the quantity, not P or Q, and not R. Alright, so in order to do this, we're going to take a look. We need the category not P or Q. So we need this category. And we need the category not R. Alright, so we're looking at these two columns here. Alright, so again, we're looking at these two columns here. Alright, what do we have? And or? And. This is the symbol combining these two columns together. In order for an and statement to be true, both must be true. That is the only time that an and statement is true, is when both are true. It's still false. If they're both false, it's still false. Alright. So, true and false.
No.
False. In order for an and statement to be true, they both must be true. And if it's false, false, it's still not both true, so it's not true. So your only time is when you see true across the board. Alright, so true and true. If it's true and true, the whole statement is true. We're looking at the category not P or Q, and the category not R. Alright, so false and false is false. False and true, false. True and false, false. So conjecture. Do we think we're going to have more truths with an and statement or fewer truths? Fewer, because you have to satisfy both requirements. Doesn't happen as often. True. False. True. So you see we only have true 3 out of the 8 times. And that is our logic table. Yes.
What are we trying to figure? Why are you doing? What's the point?
So a logic table takes a complex sentence and basically simplifies it to know whether it's true or false. So what we're not using words here, but basically we would have is 3 different statements here. And so we could have our 3 statements be I love math, I love green, I love cheese. And so then what we're looking at is this statement here of not P or Q and not R. What scenarios satisfy those requirements? So in order for this statement here to be true, I know that I need to have P and Q be true, but R be false. So let's say that these are my 3. I would need to have I love math and I love green be true, but I love cheese to be false. In that scenario, I know that this statement is true. Down here, I need false, true, false. So in order for this scenario to be true, for this statement to be true, another scenario I could have is I love math be true. I do not love green. Oh, sorry, wait, am I doing the wrong one? Sorry. I don't love math. I love green. I don't love cheese. Then that satisfies this. So then our last situation in which it's true, I don't love any of it. And that's not true for anyone. So this is basically, I wouldn't give you a sentence that would be this complex, but this is like a simplified way to look at a complex sentence and simplify to know if it's true. Yes, sir. You better believe politics every single day, whether their statements are true or false. But it's also building blocks for like definitions and things like that too. But I bet you could listen to any political speaker and think about their statements that they make and look at it as far in a conditional form, biconditional form, and or whether it's true. You can probably do a lot of that. Yes.
I think you say wrong.
This one?
Yeah, how do you do
So we need not P. Whoop, that's not what I wanted to do. That's okay. Oh, great. Now I'm really messing it up.
No, they're bubbles.
There we go. Okay. So I need to look at not P, so I need this column here. And I need to look at Q, so I look at this column here. So let me hide my other two. It's an or statement, so one of them has to be true for it to be true. True, true, false, false, true, 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 and true. Yep. Yes, sir.
What do you look at for the not?
For not P? Not P is just the opposite of P. So if it's not true, then it's false. If it's not true, it's false. Not true, false. Not true, false. So it's just the opposite of it. Not is just the opposite. Alright, other questions on this? Okay. So let's take a look at the next blurb. So logic tables aren't that bad as long as you're careful with it and take it a step at a time. When I was filling this out on my notes, I literally covered up the column with my arm or my finger to help me visualize and see what it is. So if that helps you, have a pencil and just cover up that column that you don't need to help you visualize with it. And remember, an or statement, either one has to be true or both can be true in order for it to be true. For an and statement, though, they both have to be true for it to be true. Alright, so note the first three columns represent all possible combinations of true and false for P, Q, and R. And in this table, we're looking for the true or false conclusion of our final statement under all conditions. So these are all possible scenarios, and only these three scenarios here would result in a true statement. The fourth, fifth, and sixth columns, these last ones, represent the additional information we need to make the final conclusions. On a truth problem or a truth table problem, you'll be given a table, but we'll have to fill in all the true and falses. Okay. So again, you just take it piece by piece. Be careful and look at the details when you go through. All right. Questions before we move on to the next one? What? There's more. All right. Let's look at our next example here.
There's only 4.
Yeah, so notice there's only 4 rows. Why are there only 4 rows? We only have P and Q. There's 2 possible answers for P, true or false. There's only 2 possible answers for Q, true or false. So it means we have 2 times 2 combinations, which is 4 combinations. Up here we had 2 options for P, 2 options for Q, 2 options for R. True or false, true or false, true or false. So 2 times 2 times 2 is 8, which is why we have all these combinations. So it's not near as big with only 2 statements, alright? So again, my recommendation when you set this up is your first column, do the first half true, and the second half false.
Oh.
And then for the next column, cut it in half. Well, half of 2 is 1, so we're just actually alternating there. So for your original statements, your final original statement should be alternating true, false, true, false, true, false. That, to me, is the easiest way to set it up. Oh, that looks like an E, doesn't it?
It does.
Woo-hoo! Now it's alright. Oh, what? Okay. So, not P. So I only need this column here. I'm going to go ahead and put this in. Alright, so I only need my P column. What is not P going to give us?
False.
Alright, false, false, true, true. Alright, now I'm looking at not Q. So I need my Q column. Have it my other ones. Alright, so I'm looking at just my Q column. So what is my Q column, my not Q column going to give me? False, true, false, true. Alright, so where we're finally trying to get to is not P if and only if not Q. Alright, now the reason why we have these in my table is this is my final statement I'm trying to get to, which means I need to look at not P, not Q, which means I also need to look at P and Q. That's why I have these different columns here. These first 4 columns are the components of my final response. Now let's take a look at, we know for an OR statement, either must be true in order for this to be true. For an AND statement, both had to be true in order for the AND statement to be true. But here we have that biconditional. Well, in order for a biconditional to be true, they need to both be the same. Right? So for our biconditional to be true, then both P and Q must both be true or both be false. Both are true or both false. So they're both the same. Okay, so let's take a look. We only need to look at not P and not Q. So we're only looking at those 2 columns. I'm going to hide my other ones. Okay, so that biconditional is true when both are the same. So what do we get for our final answer?
True.
True. False. False. True. Ta-da! Alright, so let's take a look at that in terms of words.
So they have to be the same.
Alright, let's go back, guys. We're not done yet. No, just because we go on the last point doesn't mean we're done. So let's take a look at this in words and terms. Yes. Because it's not P, not Q. So it's not P if and only if not Q, so I'm looking at my not P column and my not Q column. So this, to set up the truth table, since I'm trying to solve not P if and only if not Q, then that means I need not P and I need not Q. But in order to know what not P is, I need to have my original P and I need to have my original Q in order to know what the not is. So for figuring out this last column, I didn't need this. But I need all 4 pieces for the entire truth table to get each component. Because in order, if I had just these, I wouldn't know what these values are because I don't know what my starting values are for regular P and Q. Alright, so let's take a look at this in terms of words. Alright, I'm making this one off the top of my head, so we'll see how it goes. Let's say that P is I love math, and Q is I love green. Alright, so then we're trying to figure out in what scenarios, what situations make not P if and only if not Q. So not P would be I don't love math. Such a sad statement. And not Q would be I don't love green. Okay? So the only time in which these imply each other is when both are true or both are false. Alright, so the only time that that statement is true is I don't love math if and only if I don't love green. Or when they're both true. I love math if and only if I love green. That's the only time that this statement is true. That's the only 2 scenarios out of the 4 possible scenarios that that statement is true. Is when I have P and Q both be true or P and Q both be false. Questions on that? Alright. So let me go ahead and pass out your homework to you, and then I'll pass out your tests, and we'll take a look at that for the last 5 minutes before we end for the day. Remember, you do have a quiz next class over what we learned today, logic tables by conditionals, what we learned last class, law of syllogism, law of detachment, and make sure you still know converse, inverse, contrapositive. Huh? No, I'm going to pass out your homework and then pass out the test. Oh, now's a good time to go.
This paragraph is not P, something.